Hello and welcome to this presentation on low power amplifiers of the subject Applied Electronics, third semester Electronics and Telecommunication Department. Myself Sanjit Kumar Singh from the Department of Electronics and Telecommunication of Praveen Patil College of Diploma Engineering and Technology. So let's see. The learning objective after going through this presentation, the learner will be able to use transistor as low power amplifier. He or she will also be able to sketch the working principle of the given type of amplifier, calculate the gain and bandwidth of the given low power amplifier. Topics that will be learned are the classification of amplifiers, BJT as an amplifier, single stage C amplifier with the frequency response, gain, bandwidth. Rest of the topics multi-stage amplifiers will be covered in the subsequent presentation. So first chapter is of 16 marks as per marking scheme from MSBD. First we must understand what is an amplifier, then how amplifier works, what is a power amplifier. Basically an amplifier is a device, electronic circuit which produces larger electrical output of similar characteristics than that of the input parameters. The process of increasing the power of a signal by means of energy drawn from external source is called amplification. So a battery energy or external energy is required to amplify the input signal. So as we can see, the amplifier working here in the diagram, mic is the input which converts the sound signal into a small electrical signal and is given to amplifier circuit. The amplifier circuit draws power from the battery and use this energy to amplify the input from the mic. So amplified signal is then given forward to the loudspeaker and is producing back the original audio signal. So basically amplifiers can be classified into two categories, the linear amplifier and non-linear amplifier. These are the broader classification. So the amplifier in which the instantaneous output signal is directly proportional to the corresponding input signal is called linear amplifier. If not directly proportional, then it is called non-linear amplifier. So moving on, let's see the classification of amplifiers. So classification can be based on number of parameters. There are different bases. Based on the input, it could be a small signal amplifier or large signal amplifier. Based on the output, voltage amplifier or power amplifier. Based on the transistor configuration, C amplifier, CB amplifier, CC amplifier. These are the based on the transistor configurations. Biasing conditions, based on the biasing conditions, or mostly the power amplifiers that we'll study here are the biasing conditions based on the operating points, Q point. Class A amplifier, class B amplifier, class AB amplifier, class C amplifier, and there are other switching amplifiers, class D, class E, class F, class G, S, T, like that. So fifth one, nature of load resistance. Based on nature of load resistance, load could be untuned amplifier, or that is also called a wideband amplifier, amplifying the wider band of range of frequencies, say 300 kilohertz to 300 megahertz range. Tuned amplifier, narrow band amplifiers, only a selected range of frequencies input can be amplified. Then based on the frequency response, it could be direct coupled or it could be audio frequency amplifier in the audio frequency range 20 to 20 kilohertz, a radio frequency amplifier, then ultra high frequency or microwave frequency in the gigahertz too. Now the number of stages, depending upon the number of stages used. It could be single stage or multi-stage. Then based on the method of coupling between the two stages, it could be either DC coupled, where they are directly coupled, whereas in the RC coupled, resistor and capacitors are used for coupling one stage to the next stage. And if transformer is used, then the transformer coupled amplifier. Then there is also, based on the feedback, there is classification of amplifier, positive feedback amplifier, negative feedback amplifiers. So these are the major classification of amplifiers. Out of that, the power amplifiers mostly focus on say large signal amplifier, power amplifiers, and basing conditions. Based on the basing conditions, class A, class B, class A, B, and C, that we have to study. So it is important to know how BJT or transistor FET is doing the amplification. So here we see one common emitter amplifier circuit. The transistor used is NPN transistor in the C configuration, with the emitter base junction as forward based and the collector base reverse based. This is the active mode of operation of the transistor. So when there is no input signal applied Vs, when there is no Vs, then still there is IC current flowing through the transistor, and this current is called the quiescent operating current or zero current. So this current is a major source of cause of losses, wastage in the basic amplifiers. Now let's see, if input signal is applied at the base of the transistor, then for the positive half cycle, more electrons are injected into the base emitter and the base collector junctions. Remember, the flow of electrons is opposite to the direction generally marked. So due to the increase of the electrons in the two junctions, so respective currents IB and IC increases. There is also relation of IC is equal to beta times IB and I is equal to 1 plus beta times IB. So due to increased IC, the voltage drop across resistor RC also increases. RC here is the load. If externally we are not connecting any load, then RC acts as the load. So what happens when negative half is applied of the input at the base of the transistor? Then for the negative half of the input, there is lesser number of electrons injected, and hence IB and IC both decreases, and hence the voltage across RC V0 decreases. V0 decreases. So thus there is increase and decrease of the output voltage across. So IB and IC decreases, and thus we saw how amplification is done. The output obtained across RC is of larger magnitude than that of the input. So this is how BJT is acting as amplifier. Then the single stage C amplifier. Mostly the conventionally used is the single stage C amplifier with the biasing. And there are different methods of biasing: self bias, fixed bias, potential divider biasing. So here R1 and R2 are used, that is a potential division. VCC supply is divided between R1 and R2, and moreover R1, R2, RE, these three resistors are acting as the biasing resistors in order to make the transistor to operate in the amplification mode. RE, what is the requirement of the RE is it should be having high value for the DC condition and Q point stability, whereas for the AC application it should be a small. So, and moreover the voltage gain required to be very high. So both these conditions can be fulfilled if we are connecting a coupling say C amplifier that is used as a bypass capacitor. Then the two capacitors Ci and C0 at the base and at the collector are used for coupling. At the base it is coupling the input signal, whereas at the collector it is coupling the output across RC. Then how it is operated: when there is no input applied, then IB still flows, and that IB is called IBQ, and respective collector current is called ICQ, and the voltage drop across collector emitter is the VCEQ. As Vi is applied, the base current varies ever when below IBQ, and so does IC, as IC is equal to beta times IB but larger. Voltage VRC will be obviously the product of IC, the current flowing into the resistance, so that voltage also varies due to the IC varying. VC varies about VCQ, as VC is equal to VCC minus IC into RC. Now VC is coupled to the load through the CO output capacitor, coupling capacitor. V0, V output, is of the same shape as the input Vi but of larger size. Shape is similar but of larger size. Moreover, notice the inversion of the signal. The positive half, the respective output is negative half, and for the negative half input, the respective output is positive. So there is 180-degree phase shift with the single stage of C amplifier. Similarly, if we had made use of FET, then also we would have got a 180-degree phase shift. Thus amplification of Vi takes place in the single stage C amplifier. Now what is the current gain? How to calculate the current gain, voltage gain, power gain, and the bandwidth? The current gain is nothing but the ratio of IC collector current to the base current, that is also represented as a beta value. Voltage gain is V out by V in, that is in terms of current and resistance, IC into RC by IV into RI, that is equal to AI into R load by RI. Power gain can be calculated as AP equal to AI into AV. The power is product of current and voltage. That can be written as a beta times RC by R dash E. What is this R dash E? This is the AC equivalent diode emitter diode resistance, AC equivalent emitter diode resistance, where beta times R dash E is equal to Ri. And power gain, if we had to convert it into decibels, then it is 10 times log base 10 AP. Then the frequency response is plotted with respect to the frequency, gain is plotted, and from there we are calculating the bandwidth as the difference between the two frequencies, the higher cutoff frequency and the lower cutoff frequency. So it should be FH minus FL. So here we see the three regions. In the first region, say 0 to FL, a smaller frequency range. In this range, there is a decrease in gain due to the capacitive reactance of the first capacitor, input coupling capacitor, and on the right hand side again at higher frequency again there is decrease of the gain due to the stray capacitances between the junctions. In between FL and FH we see the mid frequency range, and the gain is constant, flat, more or less flat response is obtained. So the bandwidth is the difference between these two frequencies, the upper cutoff frequency and the lower cutoff frequency. Now what will be the DC equivalent circuit of CE amplifier, the circuit we saw? What will the DC equivalent circuit for that? Think for a while. For the DC equivalent, only how the current will be flowing through the DC path only. Okay, so here it is one example where at the input side there is one base RB. So we can see that capacitors, the coupling capacitors C1 and C2 are removed, and only resistors with the transistors is represented, no Vs. Okay, so what we learned in this presentation: what is amplifier, how amplifier works, then how amplification is done using BJT or BJT as an amplifier, then single stage C amplifier, we saw how to calculate the current gain, voltage gain, power gain, and the bandwidth, and obviously the classification we saw the different types of classification basis, and in particularly the based on the basing conditions, the operating Q point, the class A, B, AB and class C. So thank you. These are the references. Thank you very much.